Have you ever wondered what it would be like to drift off to sleep on the red planet? Mars isn't just a dusty, distant world. It's a place of towering volcanoes, mysterious valleys, and silent storms that have shaped its surface for billions of years. Tonight, we're going to take a gentle journey across this alien landscape, uncovering 100 fascinating facts about Mars, one soft step at a time. So, get comfortable, let your mind wander, and let the quiet wonders of Mars guide you into a dreamy exploration of our neighbouring planet. Fact 1. Mars is the fourth planet from the Sun. Have you ever gazed up at the night sky and spotted a bright reddish point of light that just seems to stand out from the stars? That's Mars quietly circling the Sun as the fourth planet in line. It's far enough to feel mysterious, yet close enough that we've been able to study it with telescopes, orbiters and rovers. Being fourth in line means Mars sits just after Earth and Venus, and before the giant planets like Jupiter. That position gives it a unique balance. It's not scorching hot like Venus, but it's also not frigid like the outer planets. Over billions of years, it's carved out its own identity, a world of dust, rocks and canyons that's surprisingly dynamic for its size. Mars' orbit is slightly elongated, which means its distance from the Sun changes a little over time. This affects the seasons, temperatures, and even the length of its days, called sols. Just knowing it's out there, orbiting steadily, can make you feel a bit more connected to the vast cosmic neighbourhood we live in. When you think about it, being fourth from the Sun is like being in the middle of a long road trip. Not too close to the start, not too far from the end. Mars has had billions of years to experience the solar system's events, and its surface tells that story. Every crater, valley, and dust dune is a page in its long, quiet history. So the next time you look up and spot that orange dot, remember, it's not just another star. It's Mars, the fourth planet from the Sun, quietly orbiting and holding secrets that humans are only beginning to uncover. Fact 2. It is often called the red planet. Mars is famous for its colour. That reddish glow that catches your eye in the night sky has earned it a nickname everyone knows, the Red Planet. And it's not just a poetic name, there's a real reason behind it. The surface of Mars is covered in iron-rich rocks and dust. Over billions of years, these minerals have oxidized, basically rusted, giving the planet that unmistakable rusty hue. Imagine the driest desert you can picture on Earth, then sprinkle in a little more iron and a lot more silence, and you start to get a sense of what Mars looks like from orbit. This colour isn't just cosmetic, it tells a story about the planet's past. Rust forms in the presence of oxygen and water, and while Mars today is dry and thinly air-covered, scientists know that water must have existed there long ago. Every reddish dune and dusty plain is like a faded photograph of a world that has changed dramatically over time. Even the way the planet glows in our night sky is influenced by that colour. Unlike stars that twinkle white or yellow, Mars shines with a soft, reddish-orange light. It's subtle but noticeable, giving it a personality that's instantly recognisable. You might even imagine, if you squint just right, that it's waving to us from millions of miles away. And that's why Red Planet isn't just a nickname. It's a glimpse into its identity. It's how we see Mars, how we imagine it, and how it captures our curiosity night after night. Fact 3. Mars is half the size of Earth. Size matters, even in space. Mars is about half the diameter of Earth, which might make it seem like a miniature version of our own planet. But that smaller size gives it unique characteristics that make it fascinating to study. Being smaller means Mars has weaker gravity, roughly 38% of what we feel on Earth. That would make jumping feel like flying and objects much lighter. Imagine tossing a ball and watching it float higher than you're used to, or trying to run and feeling almost weightless. It's a little reminder that the rules here are different, yet strangely familiar. The smaller size also affects the atmosphere. With less mass, Mars can't hold on to a thick blanket of air like Earth does. That's why its atmosphere is thin, and why surface temperatures swing so dramatically between day and night. It's harsh in its own way, but it also makes the landscape more exposed, more dramatic, more open to the mysteries of the cosmos. Even though it's half the size, Mars still manages to have massive features. The tallest volcano in the solar system, Olympus Mons, and the gigantic canyon Valles Marineris. Size isn't everything when it comes to impact. Sometimes smaller worlds hold the most surprises. Fact 4. The planet has a thin atmosphere. If you could stand on Mars without a suit, the first thing you'd notice, besides the cold, is the thin air. The atmosphere there is so sparse it's barely 1% of what we have on Earth. That thin layer of gases, mostly carbon dioxide, doesn't just make it hard to breathe, it also shapes everything on the surface. Winds whip around, carrying fine dust across plains and dunes. Dust storms can engulf the planet and last for weeks, sometimes even months. Clouds drift lazily in the sky, and frost appears on cold mornings. The atmosphere doesn't trap heat well, so temperatures swing wildly from day to night. One moment you might feel a little warmth from the sun, and the next you're in a chilling shadow. It's a delicate balance, a reminder that life as we know it relies on air in ways we often take for granted. And yet, that thinness has its charm. It gives the sky a faint pinkish hue. Soft and calm, almost like an eternal sunrise. Looking up, you can imagine the gentle movement of dust and clouds, the quiet whisper of a world different from our own, but equally alive in its subtle rhythms. Fact 5. Mars's reddish colour comes from iron oxide on its surface. It's easy to say Mars is red, but the reason behind that colour is fascinating. The soil and rocks are rich in iron, and over billions of years that iron reacted with oxygen, even in tiny amounts, creating rust all across the planet. This is why Mars looks like a giant, dusty, red desert from orbit. It's not just a pretty colour, it's a clue about the planet's history. Rust forms when metals react with air and water, and the presence of iron oxide hints that water must have flowed here long ago. Ancient rivers, lakes, and maybe even oceans left their mark in these red sands. When sunlight hits the surface, that rust reflects light in a way that gives Mars its characteristic glow in the night sky. From Earth, it doesn't twinkle like a star. It radiates a soft, steady reddish orange. That glow has captured human imagination for centuries, making Mars one of the most studied and dreamed about planets in our solar system. It's more than colour. It's a story written in minerals, dust, and time. Every sunset, every dusty plain is a reminder that this is a world shaped by natural forces over billions of years, waiting for us to continue uncovering its secrets. Fact 6. It has 2 moons, Phobos and Deimos. When you imagine Mars in the night sky, you probably picture a solitary red dot, but up close, it has company. 2 tiny moons named Phobos and Deimos. They're nothing like our moon. Instead of being round and big, they're irregularly shaped, like space rocks that got captured and never escaped. Phobos, the larger of the 2, orbits Mars so quickly that it rises in the west and sets in the east, moving faster than the planet rotates. Watching it from the surface would feel surreal, like a tiny rock chasing the sky across the horizon. Deimos, the smaller and more distant moon, moves more slowly and looks like a faint speck against the Martian sky. These moons may have started as asteroids wandering too close to Mars, eventually getting trapped by its gravity. Scientists find that idea fascinating because it's a glimpse into how dynamic and messy our solar system can be. Even tiny worlds like these have their own stories to tell. Craters from impacts, grooves etched into the surface, and subtle shifts in orbit. Though small, they matter a lot. Phobos is slowly spiralling inward and may eventually crash into Mars or break apart in the distant future. Deimos, on the other hand, is slowly moving away. Imagine a celestial dance that plays out over millions of years, so slow that it feels eternal to us, yet every movement shapes the planet's environment. Phobos and Deimos are quiet companions, orbiting silently as Mars continues its journey around the Sun. They're reminders that even the smallest objects can hold fascination, and they make the red planet feel a little more alive in the vast darkness of space. Fact 7. Mars is named after the Roman symbol of war names give meaning, and Mars has one that's unforgettable. The planet is called Mars, after the ancient Roman symbol of strength, strategy, and conflict. Of course, it's not about actual battles on the planet, but the name reflects the fiery, striking nature of its red appearance. Looking at Mars, you might understand why ancient people linked it with power. That rusty red glow in the night sky makes it look bold, persistent, and a little intimidating, like it's staking its claim in the cosmos. Over centuries, cultures have watched it carefully, noting its changes, its brightness, and the strange way it moves compared to other stars. The name also sticks because it's simple and easy to remember. Even though modern science has replaced myth with facts, the story behind the name gives the planet personality. When we talk about Mars today, we're not just talking about a celestial body, we're acknowledging centuries of human curiosity, imagination, and wonder. So while the planet is quiet and distant, its name makes it feel familiar. It's a red dot with a long story, one that connects the sky we see now to the minds of people who stared at it thousands of years ago. Fact 8. A day on Mars is called a sol, and is slightly longer than an Earth day. Time on Mars moves a little differently than it does here. A Martian day is called a sol, and it's just a bit longer than an Earth day, roughly 24 hours and 39 minutes. That extra 39 minutes doesn't sound like much, but over weeks and months it adds up, and it gives the planet a rhythm that's its own. For rovers like Curiosity and Perseverance, scientists have to plan their work around sols, adjusting their schedules to sync with Martian time. Imagine living somewhere where your day slowly drifts compared to Earth's. At first it would feel strange, almost like the planet is nudging you to notice something different. The sol also affects sunlight, weather, and temperature cycles on Mars. Morning frost melts as the sun rises, winds stir up dust in the afternoon, and long nights bring frigid cold. Understanding these rhythms is key for future explorers, but even now it gives us a sense of connection, knowing that time is passing there, just a little differently than here. Fact 9. Mars has seasons like Earth, due to its tilted axis. Mars isn't just a dry red desert. It has seasons, just like Earth. That's because its axis is tilted, similar to ours, so as it orbits the Sun, different parts of the planet get more or less sunlight throughout the year. Spring, summer, fall, and winter exist, though they last longer because a Martian year is almost twice as long as an Earth year. Seasonal changes show up in polar ice caps that grow and shrink, winds that change direction, and dust storms that pick up at certain times. Imagine winter frost on a dusty plain, followed by spring sunlight turning the landscape slightly warmer. It's a subtle rhythm, quiet and patient, stretching over months instead of weeks. Seasons also hint at the planet's past. Scientists study them to understand how water and climate behaved long ago, and how life, if it ever existed, might have adapted. It's fascinating to think that a world so distant can have such familiar cycles, almost like a heartbeat in space. Fact 10. The planet is visible from Earth. With the naked eye, Mars doesn't need a telescope to be noticed. On clear nights, you can see it glowing orange-red, standing out from stars and other planets. Its brightness changes as it orbits, sometimes shining like a tiny lantern in the sky, other times blending into the darkness. For centuries, people have looked up and spotted Mars, marveling at its glow. Its visibility makes it one of our most familiar neighbours, despite the millions of kilometres between us. Even just a moment of noticing it A tiny dot moving across the sky can spark curiosity, wonder, and a sense of connection to the wider universe. Watching Mars is like seeing a distant friend. It's always there, quietly circling, patiently waiting for us to study it, imagine it, and dream about it. Fact 11. Olympus Mons is the largest volcano in the solar system. If you thought mountains on Earth were impressive, Olympus Mons on Mars puts them all to shame. This colossal volcano rises about 22 kilometers high, nearly 3 times the height of Mount Everest. Just imagining standing at its base is enough to make your head spin, and looking down from the summit would stretch the horizon farther than most eyes can comprehend. Olympus Mons isn't just tall, it's enormous in width too, spanning around 600 kilometers across. That's wider than the state of Arizona. Its slopes are gentle but vast, slowly sloping outwards, which is why it's more like a giant shield than a jagged peak. Scientists believe it grew so massive because Mars's lower gravity allowed lava to pile up over millions of years without collapsing. Despite its size, Olympus Mons is silent today. There's no active eruption, no rumbling, just layers of hardened lava and ash marking a record of an ancient, powerful past. Standing there in imagination, you might picture Mars quietly shaping itself over billions of years, leaving behind monuments like this for future explorers to marvel at. It's hard not to feel awe when thinking about Olympus Mons. Its sheer scale is a reminder that even a smaller planet like Mars can create features far beyond anything we have on Earth. And every ridge, every slope tells a story of heat, pressure, and time stretching across eons. Fact 12. Valles Marineris is a canyon over 4,000 kilometers long. If Olympus Mons is Mars's vertical wonder, Valles Marineris is its horizontal marvel. This canyon system stretches over 4,000 kilometers, long enough to cross the entire United States from coast to coast. In some places, it's up to 7 kilometers deep, making the Grand Canyon look tiny by comparison. The canyon is a mix of steep cliffs, deep valleys and layered rock, each layer revealing hints of Mars' past. Some parts look like they were carved by tectonic forces, others hint at ancient water flows that may have slowly shaped the landscape. Walking through it, in imagination at least, feels like moving through a colossal history book written in stone. Dust swirls around the cliffs, and sunlight casts long shadows that shift throughout the day. Valles Marineris isn't just a geological feature, it's a reminder of Mars' dynamic and sometimes violent past. Every crack and slope whispers the story of a planet that, though smaller than Earth, has experienced forces of unimaginable scale. Even from orbit, the canyon is breathtaking, a scar across the Martian surface that's impossible to ignore. It's one of those features that makes you pause and realize just how dramatic another world can be, all without life as we know it standing there to notice. Fact 13. Mars has polar ice caps made of water and carbon dioxide. At the poles of Mars, ice stretches as far as the eye can see. But unlike Earth, these aren't just frozen water, they're a mix of water ice and frozen carbon dioxide, also known as dry ice. In winter, the dry ice grows and covers huge areas, then sublimates in spring, turning straight from solid to gas. These polar caps aren't static. They shrink and grow with the seasons, showing a quiet rhythm that hints at the climate cycles on Mars. Beneath the surface, layers of ice and dust accumulate over millions of years, like pages in a frozen diary. Scientists study them to understand Mars' past climate, searching for clues about water, atmosphere, and even the possibility that life could have existed long ago. Imagine standing at the edge of a Martian polar cap, a vast silent landscape of sparkling ice under a faint pink sky, wind brushing dust across the frozen plains. The poles are harsh, but strangely beautiful, a quiet reminder of how Mars holds both extremes and subtle rhythms within its landscapes. Fact 14. Its surface has many ancient riverbeds. Walk across Mars in your imagination, and you'll notice something remarkable. The surface is etched with the remnants of ancient rivers. These riverbeds twist and turn across plains and valleys, frozen reminders of a time when water flowed freely across the planet. Some river channels are narrow and winding, others spread into vast delta-like formations. They tell stories of rainfall, melting ice, and maybe even lakes that existed billions of years ago. Scientists study these channels to understand Mars' wetter past, imagining droplets tracing paths across rusty rocks long before humans ever looked up at the sky. Even though these rivers are long gone, their traces remain. They're quiet echoes of a different Mars, one that may have been more hospitable and dynamic than the dry, dusty planet we see today. Every twist in the riverbed is a clue, a reminder of time passing slowly across eons. Fact 15. Dust storms on Mars can cover the entire planet. Mars is a windy place, and sometimes it shows its power in dramatic ways. Dust storms can sweep across the planet, enveloping everything in a haze of fine red particles. Some storms are small and localized, but the largest ones can cover the entire planet, lasting weeks or even months. From above, these global storms make Mars look almost like a glowing ember, with dust swirling endlessly across plains and valleys. On the surface, winds pick up fine particles, shifting dunes and reshaping landscapes over time. Even rovers feel the effect, their solar panels sometimes buried under layers of Martian dust. These storms aren't just dramatic, they're part of what makes Mars alive, in a quiet, patient way. They remind us that even in the absence of life, planets evolve, move, and breathe in their own rhythm. Standing there, you'd feel small and awed, witnessing a force that's both gentle and immense, shaping the red planet day by day. Fact 16. The planet has rocky plains called regolith. If you could walk on Mars, one of the first things you'd notice is the endless stretches of rocky plains, often referred to as regolith. These aren't just ordinary rocks and dust. They're a layer of broken fragments, tiny stones, and fine particles that cover almost the entire surface. Think of it as a vast, dusty carpet that tells the story of billions of years of cosmic events. Regolith forms from a combination of meteorite impacts, volcanic activity, and the slow breakdown of rocks under harsh conditions. Unlike Earth, Mars doesn't have liquid water flowing over its surface today to wash things away, so this rocky layer has stayed relatively untouched, preserving the history of the planet in every grain of dust. Walking across these plains in imagination, you might picture the crunch of dust underfoot and the endless horizons stretching in all directions. The regolith might seem lifeless, but it's a record of the planet's past, ancient collisions, shifting rocks, and the slow grinding of the Martian surface over eons. Scientists study it closely because it holds clues about the planet's geology and even the history of water. Even from orbit, the regolith looks almost uniform, a quiet reddish blanket covering mountains, valleys and plains. It gives Mars that signature rusty colour and makes the planet look like a desert frozen in time. And yet, for all its quiet, the regolith is alive with stories, patiently waiting for us to uncover them. Fact 17. Some regions have giant sand dunes. Among the regolith and rocky plains, Mars surprises with something more dynamic. Giant sand dunes. These dunes stretch for kilometres, sometimes forming vast fields that ripple like the waves of an ocean frozen in motion. Wind carves and shifts these dunes over time, moving fine dust in patterns that change slowly but continuously. Imagine standing on the edge of a massive dune, looking down at soft curves shaped purely by wind. The patterns are mesmerizing, almost hypnotic, and the scale is hard to grasp. Some dunes rise hundreds of meters, casting long shadows that shift throughout the Martian day. Sand dunes are more than just beautiful. They tell scientists a lot about the planet's climate and atmosphere. By studying their shapes and movements, researchers can understand wind patterns, the frequency of storms, and even how dust is transported across Mars. Each dune is like a silent witness to the forces that still shape the red planet. Even in the middle of a quiet plain, these dunes bring a sense of motion to a world that otherwise feels still. They remind us that Mars isn't frozen in time, it's subtle, patient, and always changing in ways we're only beginning to understand. Fact 18. Mars has impact craters from ancient collisions. Scattered across Mars's surface are impact craters, some small, some enormous. Each one is a scar from a cosmic collision, a reminder that the solar system is not a static place, but a dynamic, sometimes violent environment. These craters form when asteroids or meteoroids slam into the planet at incredible speeds. The force of the impact is so great that it can create a bowl-shaped depression, scatter rocks, and even form concentric rings around the site. Some craters are relatively fresh, while others are worn down by wind and dust over millions of years. Imagine looking down into one of these craters, jagged edges, a mix of shadows and light, and the quiet knowledge that this mark was made long before humans arrived. Each crater is a timestamp in Mars' geological history, a record of events that shape the surface we see today. Impact craters also provide clues for scientists searching for water and ancient conditions. Sometimes they reveal layers beneath the surface, or hints of past volcanic activity. In a way, every crater is like a window into the planet's hidden story, waiting to be explored. Fact 19. The surface is rich in iron, giving it a rusty colour. One of the most striking features of Mars is its rusty red hue. That colour comes from the high concentration of iron in its soil and rocks. Over billions of years, the iron has oxidized or rusted, creating a fine dust that spreads across plains, dunes, and valleys. This isn't just a surface decoration. The reddish dust tells a story of Mars' past environment. Iron reacts with oxygen and water, so its widespread presence suggests that water played a role on the planet long ago. Every sunset that casts a pink-orange glow across the Martian plains is a reflection of this ancient chemical history. Walking across the rusty landscape in imagination, you might picture each step stirring fine red dust into the thin Martian air, giving the planet a soft, glowing haze. The colour is constant, changing only subtly with the light of day, yet it leaves a lasting impression. Mars is a world both familiar and alien, quiet yet undeniably vivid. Fact 20. Mars has evidence of past lava flows. If you thought Mars was just dusty and rocky, think again. Some regions show clear signs of past volcanic activity, with lava flows stretching across plains and valleys. These flows tell a story of fire and heat that shaped the planet's surface long before it became the dusty red world we see today. Lava flows are often smooth and wide, moving slowly across the terrain and leaving behind hardened rock when they cooled. Some areas appear layered, evidence of multiple eruptions over time. By studying these flows, scientists can understand Mars's volcanic history and how its interior once churned with heat and pressure. Imagining standing on a hardened lava field, you might notice the jagged edges and subtle cracks formed over millions of years. It's a reminder that Mars has been alive geologically, constantly shaping itself in quiet, patient ways. Even today, those ancient flows are a testament to the forces that once moved the red planet. Fact 21. The atmosphere is mostly carbon dioxide. If you could stand on Mars without a suit just for a moment, you'd notice one of the biggest differences from Earth: the air itself. Mars has an atmosphere, but it's very different from what we breathe. It's mostly carbon dioxide, a gas that humans can't survive on. In fact, oxygen is almost absent. This thin veil of gas plays a huge role in shaping the planet. It's too weak to trap much heat, which is why temperatures swing drastically from day to night. And it's thin enough that sunlight reaches the surface almost unfiltered, casting a pink-orange glow over dusty plains. The atmosphere may be faint, but it's alive in its own way. carrying dust, forming clouds, and giving Mars a presence beyond its surface. Even though it's mostly carbon dioxide, the atmosphere has subtle effects that make the planet feel dynamic. Wind sculpts dunes, stirs dust storms, and whispers across the rocky plains. It's delicate, almost ghostly, yet powerful enough to leave marks that endure for millions of years. Standing there, you'd feel the contrast. Fragile air, endless red plains, and a world that operates quietly yet persistently. The atmosphere may be thin, but it gives Mars a heartbeat, a rhythm that scientists are still trying to fully understand. Fact 22. Surface pressure is less than 1% of Earth's. Another surprising fact about Mars' atmosphere is just how thin it really is. The surface pressure is less than 1% of what we experience on Earth. That means the air is almost negligible, like being at the top of an impossibly high mountain on Earth, except there's no oxygen and the cold is harsher. This low pressure affects almost everything on the surface. Water can't exist as a liquid for long. It either freezes or evaporates. Dust and sand move more easily, and storms can sweep across plains with ease. Even the tiniest particle of dust is carried by the wind, reshaping the landscape over decades and centuries. For explorers and rovers, this low pressure presents challenges. Solar panels get coated with dust, instruments must be designed to survive harsh winds, and every move requires careful planning. Yet from a distance, it's also part of what gives Mars its serene, almost timeless character. A planet quiet enough to be mesmerizing, but always subtly active. Fact 23. Mars has clouds, mostly water ice clouds. Despite its thin atmosphere, Mars can form clouds. They're not like the fluffy white clouds we see on Earth. These are mostly water ice clouds, delicate and wispy, floating high above the surface. On some days you might imagine them stretching across the sky, like faint brush strokes of white against pink. These clouds often form near mountains or the poles and move slowly with the wind. They give the sky a soft texture, breaking up the uniform colour of the Martian atmosphere. Sometimes they even catch the light of the rising or setting sun, glowing faintly in shades of pink or orange. For scientists, these clouds provide clues about Mars' climate. Studying them helps us understand moisture cycles, seasonal changes, and even the history of water on the planet. And for anyone imagining standing there, they add a quiet beauty, a reminder that Mars isn't just dust and rock. It has subtle atmospheric movements, delicate patterns, and moments of calm grace. Fact 24. Dust storms can last for months. One of the most dramatic features of Mars weather is dust storms. While some are small and localized, the largest storms can engulf the entire planet and persist for months. Imagine a world wrapped in a reddish haze, the surface obscured, winds swirling endlessly across plains, craters, and valleys. These storms reshape the planet slowly but surely. Dunes shift, regolith moves, and even rover equipment can be affected, with solar panels buried under fine dust. From orbit, the planet appears almost like a glowing ember, swirling with motion that's invisible to the naked eye on the ground. Despite their intensity, these storms are silent. There's no thunder or lightning, just a quiet, persistent movement of air and dust. Standing there mentally, you'd feel small, humbled by forces that have been shaping Mars for billions of years, quietly and steadily. Fact 25. Wind speeds can reach 60 mph in storms. Even with such a thin atmosphere, Mars can have surprisingly strong winds. During storms, speeds can reach 60 miles per hour, enough to lift dust and sand, sculpting dunes and stirring ancient regolith. On Earth, winds of that strength feel powerful, but on Mars the thin air makes them gentler to the touch while still influencing the landscape. These winds carry dust across plains, sometimes depositing layers that preserve subtle patterns of time. They interact with valleys, craters, and dunes, shaping the planet silently over centuries. Even though the Martian air is light, its persistence leaves marks that endure for eons. Wind is one of Mars's subtle storytellers. It moves quietly, invisibly, yet leaves evidence of its passage everywhere, from the ripples of dunes to the dust coating the poles. It reminds us that Mars is alive in its own unique way, a planet shaped not by oceans or forests, but by thin air and patient forces acting over billions of years. Fact 26. The sky often appears reddish or pink. If you were standing on Mars and looked up, the sky wouldn't be the deep blue we're used to on Earth. Instead, it often glows in soft shades of red or pink. This is because sunlight filters through the fine dust suspended in the thin atmosphere, scattering colours differently than on our planet. The effect is subtle but magical. Morning and evening skies take on warmer tones, almost like the planet is painted with faint pastel brushes. Unlike Earth's vibrant blue days, the Martian sky has a quiet, almost meditative quality. It feels calm, distant and oddly comforting, like the planet is inviting you to slow down and notice the little details. This reddish glow also affects how the landscape looks. Rocks, dunes and plains take on a warmer tint, blending with the soft sky. Dust particles in the air scatter sunlight, giving everything a dreamlike shimmer. Even without water or clouds, the sky has its own gentle charm, a reminder that Mars is a world shaped not only by land but by light itself. Fact 27. Thin clouds sometimes create morning halos. Mars isn't entirely cloudless. Thin, wispy clouds drift across the sky, usually made of water ice, and sometimes they interact with sunlight to create faint halos during morning hours. These halos are delicate rings or arcs around the sun, subtle but visible to careful observers. It's a quiet spectacle. Nothing dramatic like Earth's thunderstorms, but enchanting in its simplicity. Imagine standing on a dusty plain, watching the soft halo glow faintly as the sun rises. Shadows stretch across dunes and rocky plains, and the ice clouds catch the first light, painting a serene scene in muted colours. These halos hint at atmospheric processes happening above the surface. They show that even on a planet with thin air and extreme cold, the atmosphere is alive, moving and interacting with light in ways that are both gentle and mesmerising. Fact 28. Mars experiences frost in winter. Even though Mars is dry, the planet can get frost in winter, especially near the poles and on higher elevations. Overnight, temperatures drop dramatically, and thin layers of frost settle on rocks, dunes and plains. The frost sparkles faintly in the weak sunlight, turning the rusty landscape into something quiet and ethereal. This frost is often a mix of frozen carbon dioxide and water ice, depending on the location. It melts or sublimates as temperatures rise during the day, leaving behind subtle changes on the ground. You can imagine waking up to a frosted Martian morning, cold, silent and peaceful, with the vast red plains stretching in every direction. Even in this harsh environment, the presence of frost hints at cycles, rhythms and patterns. It's not chaos, it's a world with gentle, predictable movements that repeat across seasons and years. Fact 29. Temperatures can swing from 120 Festus 20 to Mars's extreme. One moment it can be painfully cold, dropping to minus 125 degrees Celsius at night near the poles. The next, during a rare warm day near the equator, it can rise to a surprisingly mild 20 degrees Celsius. That's a swing of over 100 degrees, all within one planet's daily and seasonal rhythms. These temperature swings affect everything, from dust storms to frost formation. Daytime warmth can stir the regolith and move dunes, while nighttime cold preserves ice in polar caps. Living on Mars, or even imagining being there, requires respecting these extremes, understanding that beauty on this planet comes with a stark edge. Despite the harsh numbers, the temperature range contributes to Mars' quiet charm. You can almost picture the planet breathing. Cold nights, warmer days, frost forming and fading, a gentle rhythm marking the passage of time. Fact 30. The planet has seasons like Earth, but longer Mars shares something familiar with Earth. Seasons. Its axis is tilted, so as it orbits the Sun, different regions receive more or less sunlight. Spring, summer, autumn and winter exist, but each season lasts almost twice as long as on Earth, because a Martian year is nearly 687 Earth days. Seasons show themselves in polar ice caps that grow and shrink, in winds that change direction, and even in the timing of dust storms. They hint at a planet with a quiet cycle, a slow rhythm that repeats across its long orbit. Imagine waiting through a Martian winter, seeing frost grow across plains, then watching the slow arrival of spring as ice sublimates and dunes shift in the wind. These seasonal patterns make Mars feel alive in a subtle way. There's no chatter, no rivers flowing, but there is change, gradual, patient and persistent. Seasons give the red planet a heartbeat, a way to measure time and notice the world moving quietly beneath the soft reddish sky. Fact 31. Mars once had rivers and lakes. Long ago, Mars wasn't the dry, dusty world we see today. Scientists believe rivers once carved paths across the landscape, and lakes filled valleys, creating a network of flowing water that shaped the planet. Imagining it in your mind, Mars might have looked surprisingly Earth-like, with winding rivers snaking through plains and small basins of water reflecting sunlight. These ancient rivers suggest that Mars had a thicker atmosphere capable of supporting liquid water on the surface. Rainfall may have fallen, or ice melted seasonally, feeding lakes and streams. Over millions of years, this water helped sculpt valleys, canyons and craters, leaving behind clear marks that scientists can still study today. Walking across these imagined riverbeds, you might picture soft banks lined with rocks smoothed by flowing water, dry channels that once carried life-giving liquid, and plains shaped by centuries of gentle currents. Though the rivers are gone, the patterns remain etched into the planet, silent evidence of a wetter past. Fact 32. Scientists found ancient river deltas. One of the most compelling clues about water on Mars is the discovery of ancient river deltas. These formations occur where a river slows down and deposits sediment, usually at the edge of a lake or basin. The deltas on Mars are like fingerprints of a long-lost watery world, recording the movement of water over time. By studying these deltas, scientists can piece together the planet's history. The layers of sediment hint at changing climates, seasonal cycles, and even possible conditions that might have supported microbial life. Imagine looking at these layered formations in person, soft ridges and tiny cliffs, each layer a record of time, frozen in stone. The presence of deltas tells us Mars was once active and dynamic. Water flowed, sediment moved, and the landscape evolved in ways that echo processes we see on Earth. Even in its current dry state, Mars carries the memory of rivers that shaped its surface billions of years ago. Fact 33. Water exists as ice at the poles. Today, most of Mars' water exists as ice, concentrated at the polar regions. These ice caps are made of water ice mixed with frozen carbon dioxide, growing in winter and shrinking in summer. The polar ice is a window into both the planet's climate and its potential for supporting life. Standing at the edge of a Martian polar cap in imagination, you might see endless white plains sparkling under the weak sunlight, contrasting sharply with the red dust of nearby plains. Ice layers are layered like pages in a book, preserving records of seasonal cycles and atmospheric changes across millions of years. The polar ice is fragile yet persistent. It grows and recedes quietly, a testament to Mars's slow but steady rhythms. Even in this harsh environment, water exists, waiting to be studied and understood, hinting at the planet's watery past. Fact 34. Some underground lakes might still exist. While surface water is gone, scientists believe Mars might still hide water underground. Subsurface lakes could exist beneath thick layers of ice, shielded from the harsh surface environment. These hidden reservoirs are intriguing because they may have remained liquid due to salts and geothermal heat. If these underground lakes exist, they could provide clues about past habitability. Imagine drilling through layers of ice and dust to reach a hidden, still-flowing lake, untouched for millions of years. It's a reminder that Mars is not just a dry desert. It's a planet with secrets, quietly holding on to water in places we can't easily see. These lakes are like quiet whispers of life's possibility, a reason to keep exploring, imagining, and studying the red planet. They make Mars feel alive in hidden, mysterious ways under the surface we see from orbit. Fact 35. Mars' atmosphere can produce small amounts of water vapor. Even today, Mars' thin atmosphere can produce tiny amounts of water vapor. Dust storms, wind, and temperature changes allow minuscule quantities of water to evaporate and circulate through the air. It's not enough to form rivers or rain, but it demonstrates that water is still present, moving slowly in cycles we're only beginning to understand. This water vapor interacts with dust and ice, forming thin clouds and even frost. It shows that Mars' atmosphere, while thin and mostly carbon dioxide, is dynamic and active. Small as it is, this water cycle hints at processes that could support life in the past, or even in isolated pockets today. Looking at Mars, knowing there's still a whisper of water in its atmosphere, makes the planet feel less lifeless. It's a world quietly breathing, changing and holding on to elements of its past, waiting for us to study, imagine, and perhaps explore directly one day. Fact 36. Permafrost may cover large areas. Beneath Mars' dusty plains and rocky surface lies a hidden layer that few can see: permafrost. Much like the frozen soils found in Earth's polar regions, Martian permafrost is a mix of water ice and soil, locked in a deep freeze that has persisted for millions of years. Permafrost isn't just a frozen relic, it's a clue to the planet's watery past. Scientists think vast stretches of Mars may be covered by this icy layer, especially at higher latitudes and near the poles. If you could dig through it, you'd find ice preserved in its natural state, a silent record of seasonal changes, climate shifts, and possibly even past habitats for microscopic life. Standing in imagination on a Martian plain, you might picture gently shifting dust over frozen ground, silent and still, while the ice beneath remains intact, hidden from view. This frozen layer is patient, enduring, and waiting for humans to explore its secrets. It's another reminder that Mars holds stories beneath the surface, quietly shaping the planet for anyone curious enough to study it. Fact 37. Liquid water is unstable on the surface today. If you were to pour water directly onto Mars's surface, it wouldn't last long. The thin atmosphere and low pressure make liquid water unstable. It would either freeze instantly or evaporate into vapor. That's why rivers, lakes, or oceans cannot exist on Mars today, even though evidence shows they were once abundant. This instability doesn't mean Mars is completely dry. Frozen ice, frost, and minimal water vapor still exist. But liquid water is fleeting, and any remaining water tends to hide in protected areas, like under ice layers or within salty brines. Imagine watching droplets form and vanish almost immediately, a reminder of how harsh and delicate the environment is. The instability of liquid water highlights the challenge for any future explorers. Water is a critical resource, and yet Mars holds it mostly in frozen or underground forms. It's a world where patience and ingenuity would be necessary to access something as simple as a drink of water. Fact 38. Ancient Mars may have had oceans billions of years ago. Mars may have been a very different planet. Some scientists believe vast oceans once covered parts of the northern hemisphere, stretching across plains and basins that are now dry and dusty. These oceans would have created a climate more temperate than today, with flowing rivers feeding the seas and possibly lakes dotting the landscape. Imagine looking across a Martian ocean in the distant past, water glimmering under a pale sun, ice forming at the poles, and gentle waves carving shores over centuries. That vision is hard to reconcile with the Mars we know today, but the planet's surface preserves clues: ancient shorelines, sediment patterns, and valley networks hinting at a wet, dynamic world. These ancient oceans inspire curiosity about Mars's habitability. Could life have existed in these waters? Even without answers yet, they tell a story of change, a transformation from a potentially watery planet to the arid red world we see now. Fact 39, seasonal flows called recurring slope lineae suggest briny water. In recent years, scientists have observed curious dark streaks on steep slopes of Mars known as recurring slope lineae, RSL. These streaks appear during warmer months and fade when temperatures drop, hinting at the presence of briny, salty water that flows just enough to leave visible traces. Briny water can stay liquid at lower temperatures than pure water, allowing these flows to exist even in Mars's harsh environment. Imagine thin, dark rivulets moving slowly down a dusty canyon slope. Subtle, almost imperceptible, yet alive with movement. These seasonal flows are exciting because they show that liquid water isn't entirely gone from Mars, even if it's rare and briny. RSL may be one of the best clues for locating areas where life could potentially survive today. They show the planet is not completely inert. There are cycles, movement, and tiny oases of liquid water waiting to be studied. Fact 40. Scientists search for life in these water-rich areas. All these traces of water, ice, permafrost, ancient riverbeds, and recurring slope lineum make Mars a prime target in the search for life. Scientists focus on water-rich areas because, as on Earth, water is essential for life. Even microscopic life would need some liquid to survive, and Mars may preserve tiny traces in hidden or seasonal water flows. Robotic explorers like Curiosity and Perseverance drill, scoop, and analyze Martian soil in hopes of uncovering organic molecules, minerals formed in water, or chemical signatures of past life. Imagine a rover inching across a dusty slope, studying tiny rocks and ice, uncovering the whispers of a long-lost world. Mars may seem dry and lifeless, but these hidden water-rich zones hint at a quieter, hidden vitality. They remind us that even in the most extreme environments, life might have once thrived, or could perhaps persist in ways we've yet to understand. Fact 41. Mars has two moons, Phobos and Deimos. Mars isn't wandering through space alone. It has two small companions, Phobos and Deimos. Unlike Earth's moon, these moons are tiny and oddly shaped, more like oversized space rocks than perfect spheres. Phobos, the larger, looks pockmarked with craters, while Deimos is smoother and smaller, appearing almost like a pebble floating in the sky. These moons orbit Mars quietly, moving along predictable paths but giving the planet a sense of companionship. They are constant observers, silently circling the red planet as it traces its path around the sun. Their presence reminds us that even a planet that feels isolated in the night sky has neighbours, sharing its orbit in a delicate cosmic dance. Phobos and Deimos aren't just celestial decoration, they're intriguing clues to Mars' history. Their small size and irregular shape suggest they didn't form alongside the planet, but may have been captured asteroids, wandering too close and getting trapped by Mars' gravity. Studying them helps scientists understand not just Mars, but the dynamic behaviour of the solar system itself. Fact 42. Phobos is slowly spiralling toward Mars. Phobos has a secret. It's slowly moving closer to Mars. This small moon, orbiting extremely fast, faster than Mars rotates, gradually loses altitude due to tidal forces. Over millions of years, it may either crash into the planet or break apart, forming a ring of debris. Imagine watching Phobos in the sky over centuries. Right now, it rises in the west and sets in the east, a tiny, fast-moving object streaking across the reddish sky. But over long spans of time, it will edge closer and closer to the planet. a silent countdown written in orbital mechanics. Its gradual descent is a reminder of the slow, persistent forces shaping the solar system. Even tiny moons have their destinies, dictated by gravity, time, and motion, showing that Mars' environment is constantly evolving, even if we can't perceive the changes in a human lifetime. Fact 43. Deimos is slowly moving away. In contrast to Phobos, Deimos is slowly drifting away from Mars. Its orbit expands imperceptibly over time, making it a quiet wanderer in the sky. While it moves more slowly than its sibling, it still shares the same basic story. Small moons shaped by gravity, tracing delicate paths around the red planet. Deimos's outward movement may seem subtle, almost poetic, as if the smaller moon is gently escaping the planet's embrace. Over millions of years, it will continue to drift further, eventually becoming more distant in Mars's sky. A reminder that even in the seeming stillness of space, change is always happening. Studying Deimos helps scientists understand tidal forces, orbital dynamics, and the long-term evolution of moons. It also gives us a unique perspective. Two moons, connected to the same planet but moving in opposite directions over eons. A cosmic lesson in patience and slow transformation. Fact 44. Both moons are small and irregularly shaped. Phobos and Deimos aren't like the moon we see from Earth. They are small, rocky, and irregularly shaped, more akin to giant potatoes than spheres. Their uneven surfaces are covered in craters, grooves and ridges, telling stories of ancient collisions and the slow grind of space debris over billions of years. This irregularity gives the moons a unique charm. From Mars's surface, Phobos looms larger, with pockmarks and shadows shifting across its surface. Deimos appears faint and smooth, almost toy-like as it moves across the sky. Their odd shapes remind us that nature doesn't always produce perfection. Sometimes it creates quirk, variation, and endless fascination. By studying their shapes, scientists gain insight into their origins, compositions, and histories. Every crater, ridge, and curve is a page in the moon's long story, quietly orbiting Mars and whispering secrets of the solar system. Fact 45. They may be captured asteroids. The origins of Phobos and Deimos are still debated, but many scientists think they are captured asteroids. Their irregular shapes, small sizes, and composition suggest they didn't form with Mars itself. Instead, they may have wandered too close, caught by gravity, and settled into orbit. If this is true, these moons are visitors that never left, a reminder that the solar system is dynamic and interconnected. Asteroids drift, planets capture, and small rocks can become long-term companions for billions of years. It's a story of chance, gravity, and time, showing that Mars' quiet skies are home to objects with remarkable histories. Thinking about this, you realize that Mars' moons aren't just decoration, they are storytellers. They speak of ancient asteroids, of movement across space, and of the subtle, persistent forces that continue shaping the red planet today. Fact 46. Phobos orbits Mars faster than Mars rotates. Phobos is a fast little moon. Unlike Deimos, it completes its orbit in just about 7.5 hours, which is faster than Mars itself rotates. That means if you were standing on the surface, Phobos would rise in the west and set in the east. An unusual sight compared to the moon on Earth, which slowly drifts across the sky. Watching Phobos streak across the Martian sky, you might feel a sense of motion and urgency. It's small, irregularly shaped, and yet it moves with relentless precision, completing more than 3 orbits every single Martian day, or sol. Its rapid pace is a quiet reminder of the delicate balance between gravity, orbit, and motion, showing that even tiny celestial bodies can have dynamic lives. Phobos' speed also contributes to its eventual fate. Because it orbits so close and so quickly, tidal forces gradually pull it inward toward Mars. One day, it may spiral too close, a slow but inevitable collision billions of years in the making. For now, it's a fast-moving companion, silently marking time in the Martian sky. Fact 47. Deimos takes about 30 hours to orbit Mars Deimos. The smaller of Mars's moons is much more leisurely. It takes around 30 hours to complete a full orbit, moving more slowly than Phobos and even slower than Mars's rotation. To an observer on the surface, Deimos rises in the east and sets in the west, drifting slowly across the sky like a quiet, patient traveller. Its gradual motion gives Deimos a calm presence, contrasting sharply with the frenetic pace of Phobos. Over nights and days it moves imperceptibly, appearing as a small pale dot that adds a subtle rhythm to the Martian sky. While tiny and irregular, Deimos serves as a quiet companion to Mars, a reminder that the red planet is never truly alone. This slow orbit also gives scientists clues about its composition and origin. Unlike Phobos, which orbits close and fast, Deimos's distant leisurely path suggests stability over long timescales. Its presence paints a picture of Mars as a planet with companions of different personalities, one fast and fleeting, the other slow and steady. Fact 48. Phobos has a giant crater named Stickney. Phobos isn't just a fast-moving moon, it has personality too, marked by a huge crater named Stickney. This crater dominates Phobos' surface, stretching nearly 10 kilometers across, making it impossible to miss. Its formation likely came from a massive impact long ago, a violent event that left permanent scars. The crater gives Phobos a pockmarked, rugged appearance, with grooves and fractures radiating from Stickney like cracks on a weathered surface. Standing on Mars and imagining looking up at Phobos, you'd notice the crater's shadow and its dramatic presence, a reminder of the power of collisions in the solar system. Stickney also helps scientists study the moon's interior. The grooves and fractures reveal how Phobos responds to stress, gravity and impacts. Even though it's small and irregular, this tiny moon has a complex story written in a rock and shadow, orbiting Mars silently through the centuries. Fact 49. The moons cast small shadows on the planet. Despite their small sizes, Phobos and Deimos cast shadows on the Martian surface. Phobos can even create a partial solar eclipse, briefly dimming sunlight as it passes between Mars and the Sun. Deimos, being smaller and more distant, casts a faint shadow that drifts slowly across plains and valleys. These shadows are tiny but noticeable, moving across the landscape like subtle reminders that Mars has companions watching over it. Imagine standing on a Martian plain, feeling the momentary dimming as Phobos passes overhead, a fleeting connection between planet and moon. These shadows are more than aesthetic. They demonstrate the moon's motion, size and distance, giving scientists natural clocks to track their orbits and learn about their dynamics. Even in their quiet presence, they interact with the planet below, leaving impressions that can be observed and measured. Fact 50. Scientists hope to explore them someday. Phobos and Deimos aren't just curiosities, they're targets for exploration. Scientists hope to send missions to study their surfaces, composition, and origins. These moons may hold clues about Mars' past, the history of captured asteroids, and the formation of small celestial bodies in the solar system. Exploring them could reveal secrets about water, minerals, and perhaps even resources for future human missions to Mars. Imagine landing on Phobos or Deimos, stepping onto their cratered, rugged surfaces, and looking out at Mars hovering in the sky, a small red world beneath your feet. Their exploration promises answers to questions we've long wondered about. Where did they come from? How do small moons survive the harshness of space? What do they tell us about the red planet's history? For now, Phobos and Deimos quietly orbit, waiting for humanity to visit and uncover their hidden stories. Fact 51. The first Mars flyby was Mariner 4 in 1965. In 1965, humans got their first close glimpse of Mars thanks to Mariner 4. This little spacecraft zipped past the red planet, sending back the very first photos of its surface. Before Mariner 4, Mars existed mostly in imagination, telescopes, and speculation. Suddenly, we had real images, craters, plains, and a rugged landscape unlike anything Earth had to offer. Mariner 4 didn't just take pictures, it changed how we saw Mars. The photos revealed a barren, cratered world, a place both familiar and alien. It was the start of a new era, the beginning of our direct exploration of another planet. Scientists could now study the surface remotely, planning for future missions with more precision. Imagine watching those grainy black and white images arrive on Earth, each photo a tiny window into a distant world. Mariner 4 set the stage for decades of exploration, proving that even from millions of kilometers away, we could connect with Mars in a way that was once pure science fiction. Fact 52. Viking 1 was the first successful lander in 1976. A little over a decade later, humans achieved a giant leap, landing on Mars. Viking 1 touched down in 1976, becoming the first successful lander on the Martian surface. Unlike Mariner 4, Viking 1 didn't just pass by, it stayed, studying the planet directly from the ground. Viking 1 sent back astonishing data, images of the landscape, measurements of the atmosphere, and experiments searching for life. Its colour photos revealed red soil, dusty plains, and rocks scattered across an alien horizon. For the first time, we saw Mars not just as dots in a telescope, but as a real, tangible place we could explore. The success of Viking 1 inspired generations of scientists and engineers. It proved that landing on another planet was possible, paving the way for rovers, orbiters, and future missions. Imagine the thrill of engineers monitoring its signals, knowing that a human-made machine had safely touched down millions of kilometers away, ready to study the unknown. Fact 53. Mars Pathfinder brought the first rover, Sojourner fast forward to 1997, and Mars Pathfinder changed exploration once again. This mission brought the first rover, Sojourner, onto the Martian surface. Unlike stationary landers, Sojourner could roam, examining rocks, soil, and small features across its landing site. Sojourner was tiny, just a few kilograms, but it had a huge impact. It demonstrated that mobile exploration on another planet was possible, providing real data on Martian terrain, dust, and rock composition. Watching it move across the surface in your imagination, you can picture it slowly climbing over rocks, rolling across dusty plains, and sending images back to Earth. Mars Pathfinder and Sojourner ignited excitement worldwide. People could follow a tiny robot as it explored a distant world, giving humanity a taste of what it's like to roam Mars without leaving Earth. It was playful, pioneering, and inspiring all at once. Fact 54. Spirit and Opportunity explored Mars for years. Spirit and Opportunity were a pair of rovers that took exploration to a new level. Launched in 2000, they were designed to last just a few months, but they kept going for years, uncovering landscapes, rocks, and clues about water on Mars. Spirit explored the Western Hemisphere, climbing hills and studying mineral deposits. Opportunity, meanwhile, roamed far across the plains, documenting evidence of ancient water and leaving tracks that stretched for kilometers. Both rovers sent back thousands of images, revealing canyons, craters, and dune fields in exquisite detail. These rovers weren't just machines, they became ambassadors. People imagined them moving across Martian valleys, overcoming obstacles and quietly enduring the harsh climate. They showed that persistence pays off, and even tiny robots can teach us enormous lessons about distant worlds. Fact 55. Curiosity rover studies geology and climate. Curiosity, launched in 2010, is one of the most advanced rovers on Mars. Unlike its predecessors, it carries a full laboratory, capable of analysing soil, rocks, and the atmosphere. Its mission is to understand Mars's geology, climate history, and whether it could ever have supported life. Driving across Gale Crater, Curiosity examines layered rocks, ancient riverbeds, and sediment deposits. It measures radiation, monitors weather, and even studies seasonal patterns. Its discoveries have reshaped our understanding of Mars, showing that it was once warmer and wetter, with conditions that might have supported microbial life. Imagine following Curiosity in your mind, a large robotic explorer moving slowly across the rusty plains, analysing rock after rock, sending back data that expands humanity's knowledge of another planet. It's patient, methodical, and endlessly curious, a perfect reflection of our own desire to understand Mars. Fact 56. Perseverance rover searches for signs of ancient life. Perseverance, the newest of Mars rovers, carries a mission full of ambition, searching for signs of ancient life. Unlike earlier rovers that mostly studied rocks and soil, Perseverance examines locations where water once existed, looking for chemical signatures that might hint at past microbial life. Its landing in Jezero Crater placed it in a region thought to be home to an ancient river delta. You can imagine the rover methodically moving across the crater floor, collecting samples, drilling into rocks, and analysing sediments layer by layer. Each rock tells a story, whispering secrets about the planet's history. Perseverance also collects samples to be returned to Earth someday. Scientists hope to study these samples with advanced laboratory equipment impossible to send to Mars, bringing Martian history directly to our planet. It's a meticulous mission combining patience, precision, and curiosity, proving that even in a harsh environment, exploration can be methodical and thorough. Fact 57. Ingenuity helicopter performed first flight on another planet. Accompanying Perseverance is a small but remarkable companion, Ingenuity, a helicopter designed to fly in Mars' thin atmosphere. In April 2021, it made history with the first controlled flight on another planet. Imagine a tiny drone hovering above the rusty plains, spinning its rotors in the nearly invisible air and sending images back to Earth. Ingenuity isn't just a technological marvel, it's a proof of concept. Flying in an atmosphere less than 1% as dense as Earth's is extremely challenging. Each flight required careful planning, precise engineering, and the patience to learn from every attempt. Watching Ingenuity's flights, you'd see a delicate mechanical bird soaring over craters and dunes, scouting terrain for Perseverance, and showing that exploration doesn't have to be limited to wheels. It's a first step toward using aerial vehicles to map, scout, and explore places humans haven't yet reached. Fact 58. Orbiters like Mars Odyssey scan the surface from above, while rovers explore Mars from the ground. Orbiters like Mars Odyssey take a bird's-eye view. Circling the planet for years, these orbiters scan the surface, map mineral compositions, and detect water ice hidden beneath dust and regolith. From above, Mars appears both familiar and mysterious. Orbiters capture sweeping images of vast plains, deep canyons, and towering volcanoes. They help scientists pinpoint landing sites, track weather, and understand seasonal changes. Orbiters act as the silent guardians of Mars, constantly observing and sending data back to Earth. Their high vantage point provides context for everything happening on the surface. While rovers dig, drill, and drive, orbiters see the bigger picture, connecting individual findings into a planetary story. Together, ground and sky exploration reveal Mars in ways no single mission could achieve. Fact 59. The ExoMars mission aims to dig underground. The ExoMars mission, a collaboration between ESA and Roscosmos, takes exploration a step further by aiming to dig underground. Its rover, Rosalind Franklin, is designed to drill up to 2 meters beneath the surface, where organic material could be preserved from harsh radiation and dust storms. This is important because Mars's surface is exposed to extremes, ultraviolet radiation, thin air, and dust that can destroy delicate chemical traces. Underground, secrets of the planet's past may remain intact. Imagine uncovering hidden layers of soil, ancient sediments, and possibly tiny signs of life, all protected beneath the rusty crust. ExoMars represents the next frontier in searching for life. It's a reminder that exploration is evolving, from flybys and landers to rovers, helicopters, and now digging into the hidden depths of a distant world. Fact 60. SpaceX plans future human missions to Mars. Beyond robots and orbiters, humans have set their sights on Mars. SpaceX, led by Elon Musk, has ambitious plans to send people to the Red Planet within the next few decades. The vision involves reusable rockets, massive spacecraft, and colonies that could eventually make Mars a second home for humanity. While it's still in development, imagining human missions sparks excitement. People walking across red plains, climbing crater rims, and exploring ancient riverbeds brings the distant planet into a relatable perspective. Robots have paved the way, scouting terrain, studying hazards, and providing knowledge to make human exploration safer and more achievable. These plans remind us that Mars isn't just a distant object in the night sky, it's a place we hope to touch, explore, and perhaps even live on one day. The dream of human footprints on Mars combines technology, imagination, and the timeless curiosity that drives us to look up and wonder. Fact 61. Mars has basaltic rocks from lava flows. Mars is a planet shaped by fire as much as by dust. Vast regions are covered in basaltic rocks, the hardened remnants of ancient lava flows. Imagine molten rock slowly oozing across plains and craters millions of years ago, shaping valleys, plateaus, and hills. Over time, these flows cooled into solid, dark rock, forming the foundation of much of Mars's surface. These basaltic rocks aren't just static stones, they're storytellers. Each layer preserves clues about volcanic activity, the planet's interior, and the intensity of eruptions in Mars' past. By studying their composition, scientists can understand how the planet cooled, how its crust evolved, and how volcanic activity influenced the atmosphere and climate. Walking across these imagined lava plains, you might picture vast, solidified rivers of rock stretching endlessly under the reddish sky, a silent testament to the planet's fiery beginnings. Basalt is a constant reminder that Mars was once geologically active, a world alive with heat and movement beneath its surface. Fact 62. Sulfates on the surface suggest past water. In many Martian regions, scientists have found minerals called sulfates, formed when water interacts with the rock over long periods. Their presence suggests that Mars wasn't always dry. It once had water flowing, pooling, and chemically altering the surface. Sulfates tell a story of ancient chemistry. They indicate that water not only existed but actively shaped the landscape, dissolving minerals, creating sediments, and leaving behind chemical fingerprints. Imagine a dusty plain where sulfate-rich layers once formed under shallow lakes or evaporating pools. Even though the water is gone, the minerals remain, quietly preserving the past. These discoveries excite scientists because they provide evidence of habitable conditions long ago. Where there was water, life might have been possible. Sulfates act like a geological diary, chronicling the movements and transformations of water across time on Mars. Fact 63. Clay minerals indicate long-lasting water presence. In addition to sulfates, clay minerals on Mars hint at a wetter past. Clays form when water interacts with rock over extended periods, requiring stable conditions for chemical reactions to occur. Their discovery suggests that Mars had regions with long-lasting, possibly gentle water activity, not just brief floods. Clay-rich deposits often appear in ancient riverbeds or lake basins. Imagine soft, fine layers of sediment accumulating over centuries, slowly altering the chemical makeup of the soil. These minerals tell scientists that Mars wasn't just episodically wet, it had environments that might have persisted long enough to support life, at least at a microbial scale. Clays are like markers of habitability, highlighting regions where water lingered and conditions were mild enough for chemistry and potentially biology to take hold. They transform Mars from a barren desert into a planet with a deep and dynamic history. Fact 64. Hematite blueberries were discovered by Opportunity rover made a surprising discovery. Tiny, round, iron-rich spherules nicknamed blueberries. These small spheres, scattered across Martian plains, are composed of hematite, a mineral that forms in the presence of liquid water. The blueberries are scattered like miniature beads, sometimes forming dense clusters. They offer strong evidence that water once existed in significant quantities, interacting with rocks over long periods. Imagine Opportunity rolling past a dusty plain, its cameras capturing these tiny spheres glinting in the Martian sunlight, an almost whimsical sign of a watery past. These blueberries aren't just geological curiosities, they're proof that Mars had active chemistry involving water. They also give scientists a way to track the planet's environmental changes, revealing conditions that might have been favourable for life long ago. Fact 65. Iron-rich rocks give the red colour. Mars' iconic red colour comes from iron-rich rocks and dust. When iron minerals on the surface oxidize, they form rust, turning the landscape into the reddish-orange world we recognise from Earth. Walking across imagined Martian plains, you'd notice the rusty soil, the dust kicked up by winds, and the subtle red hue that dominates the horizon. This colour isn't just aesthetic, it reflects the chemical history of the planet, the oxidation of iron over billions of years. The red dust also affects the sky, scattering sunlight and giving Mars its pinkish-reddish glow during sunsets and sunrises. Iron-rich rocks are everywhere, reminding us that even something as simple as colour carries deep geological stories about how the planet evolved over time. Fact 66. Mars has ancient, heavily cratered highlands. The Martian highlands are some of the oldest landscapes in the solar system. Covered in craters, these elevated regions tell a story of countless collisions over billions of years. Imagine standing on a Martian plateau, looking around at countless pockmarks in the surface, each one a scar from a meteorite or asteroid impact. These highlands are more than just old. They're records of the planet's past. The number, size, and distribution of craters help scientists estimate the age of the surface and understand the intensity of impacts over time. Some craters are enormous, spanning tens of kilometers, with rims and ejecta creating intricate patterns across the terrain. Walking across this imagined landscape, you'd feel the weight of time. The highlands are silent witnesses, preserving the memory of a violent past while offering clues about Mars' early environment, crust, and geological history. They are a reminder that even in quiet stillness, a planet can hold stories older than human history. Fact 67. Younger plains show volcanic activity. In contrast to the ancient highlands, some Martian plains are younger and shaped by volcanic activity. These regions have smooth surfaces, evidence of lava flows and formations created by eruptions that occurred after the planet's early bombardment period. Imagine broad, dark plains stretching toward the horizon, cooled lava flows crisscrossing the surface, and volcanic cones rising in the distance. These areas show that Mars wasn't just a static world, it experienced dynamic geological processes long after its early formation. Volcanic activity on Mars shaped the atmosphere and surface, possibly even influencing the presence of water. The interaction of heat, rock, and minerals created layers that scientists study today, revealing a planet that has been active, changing, and evolving for billions of years. Fact 68. Mars's soil may contain perchlorates. Mars's soil has a hidden chemical twist, perchlorates. These salts are toxic to many Earth-based organisms, but they also hint at water chemistry. Perchlorates can lower the freezing point of water, potentially allowing tiny amounts of liquid brines to exist in extreme conditions. Imagine scooping up Martian soil and discovering these invisible salts, scattered throughout dust and rock. They're like hidden markers, showing how the surface interacts with the atmosphere, temperature changes, and possibly ancient water. Perchlorates are both a challenge for potential life and a clue about the chemical complexity of Mars' soil. For scientists, these salts are a puzzle: how they formed, how they interact with water, and what they reveal about past environmental conditions. Even in small amounts, they hold big stories about the red planet's history and habitability. Fact 69. Sand dunes shift with the wind. Mars isn't frozen in place. Its sandy regions are dynamic, with dunes that slowly shift under the influence of the wind. These dunes move just a few meters per year, carving patterns across plains and valleys, shaped by the constant whisper of Martian breezes. Imagine standing on a dune field in your mind's eye. Soft, fine grains rolling down gentle slopes, ripples forming like waves in a desert sea. Even though Mars's air is thin, it still moves dust and sand, shaping the landscape over centuries. These shifting dunes tell scientists about wind patterns, seasonal changes, and the forces at work on the surface. They are living records of the planet's climate, slowly dancing across the red planet like subtle signatures of motion over time. Fact 70. Dust storms carry fine particles across the planet. Mars is famous for its dust storms, some small and localized, others massive enough to cover the entire planet. These storms lift fine particles, carrying them across plains, valleys, and craters, sometimes for months at a time. Imagine a faint reddish haze creeping over the horizon, obscuring features, dimming sunlight, and moving like a slow-moving tide. Dust storms shape the surface, deposit layers of soil, and even affect temperatures and weather patterns. For rovers and orbiters, these storms are both a challenge and an opportunity. They obscure cameras, cover solar panels, and shift dunes, but they also reveal the planet's active environment. Mars isn't frozen and lifeless. It's dynamic, with winds that tell stories of movement, change, and a world still very much alive in its own way. Fact 71. Mars' thin atmosphere cannot protect from radiation. Mars' atmosphere is thin, less than 1% the pressure of Earth's, and that has consequences. Unlike Earth, which has a thick shield of air and a magnetic field to block harmful radiation, Mars' surface is exposed to cosmic rays and solar radiation. Imagine standing on a Martian plain. The sky looks soft and pink, but above you, space radiation streams through unimpeded. This makes the surface harsh for life and challenging for explorers. Any organism or human visitor would need protection from these invisible but powerful rays. Scientists study radiation on Mars to understand its effects on the planet's surface and what would be required for human missions. It's a stark reminder that Mars is alien, not just in appearance, but in the invisible forces shaping it, from radiation to dust storms. Fact 72. Temperature swings are extreme day to night. Mars experiences wild temperature swings. During the day, temperatures can reach up to 20 degrees Celsius in the warmest regions, but by night, they can plummet to around minus 125 degrees Celsius. Imagine standing on a crater rim at sunrise. The ground is cold, the sky tinged red, and by sunset, everything freezes again. These swings are a result of the thin atmosphere which cannot retain heat. The planet heats quickly under sunlight and cools almost as fast when night falls. Such extremes shape the surface, the behaviour of dust, ice, and even the potential for liquid water. Life as we know it would struggle in this environment, but the dramatic temperature changes also tell the story of a world constantly shifting between extremes. Fact 73. The planet has a weak greenhouse effect. Mars has a very weak greenhouse effect. Its atmosphere is mostly carbon dioxide, but because it is so thin, it cannot trap heat effectively. This means the planet cannot retain warmth, contributing to its frigid nights and limited ability to support liquid water on the surface. Imagine the Martian day. Sunlight warms the surface quickly, but as soon as the sun sets, the heat escapes into space. The weak greenhouse effect emphasizes that Mars is a cold, desert-like world, where conditions fluctuate sharply and survival is a challenge. Understanding this greenhouse effect is crucial for scientists planning human missions. If humans want to live on Mars, they'll need ways to manage temperature extremes and create habitats that can compensate for the planet's fragile atmosphere. Fact 74. Dust in the air scatters sunlight and reddens the sky. The reddish hue of Mars isn't just from iron-rich soil, it extends into the sky. Fine dust particles in the atmosphere scatter sunlight, creating a pinkish or reddish tint overhead. Sunsets appear softer, and the horizon often glows with subtle red tones, giving Mars its characteristic appearance. Imagine looking up on a dusty Martian afternoon. The sky has a muted glow, shadows stretching over red plains, and everything feels tinted with the colour of the planet itself. The dust is constantly moving, shifted by winds, and it affects everything from temperature to solar energy reaching rovers and orbiters. This dusty atmosphere makes Mars unique, blending surface and sky in the same rusty palette, and offering scientists hints about wind patterns, seasonal changes, and climate behaviour over time. Fact 75. Clouds sometimes form near volcanoes. Despite its thin atmosphere, Mars can form clouds. Often these clouds appear near tall volcanoes, shaped by orographic lift as air rises over peaks. They are typically thin, wispy, and made of water ice, drifting quietly across the sky. Imagine standing at the base of Olympus Mons or one of the other giant volcanoes and watching delicate clouds glide past the summit. These clouds hint at subtle interactions between the atmosphere, temperature, and topography. While they are far from the heavy cloud systems on Earth, Martian clouds still reflect cycles of moisture, wind, and temperature. They offer scientists clues about local weather, the potential movement of water vapor, and the dynamic processes still at work in the red planet's thin, fragile atmosphere. Fact 76. Martian winter causes CO2 to freeze at poles. During the Martian winter, temperatures drop so low that carbon dioxide from the atmosphere freezes and forms seasonal polar caps. Imagine the poles blanketed in frost, not just water ice, but dry ice, shimmering faintly under the pale sunlight. These frozen layers grow and shrink with the seasons, creating one of Mars' most dramatic transformations. The freezing of CO2 affects the atmosphere itself. As gas condenses into ice, air pressure drops, winds shift, and the planet experiences a subtle but planet-wide seasonal cycle. For scientists, these cycles reveal how Mars breathes with its seasons, even without oceans or dense clouds. Standing at the pole in your imagination, you'd see a sparkling white landscape, a silent, frozen testament to Mars' extreme climate. It's a visual reminder that this planet isn't static. It changes, breathes, and responds to the sun in ways both beautiful and extreme. Fact 77. Spring brings sublimation of dry ice. When spring arrives, the frozen CO2 caps begin to sublimate, turning directly from solid dry ice back into gas. Imagine a gentle hissing as the ice evaporates, releasing carbon dioxide into the thin atmosphere and slowly reshaping the polar landscape. This process drives seasonal winds and can even trigger small dust storms as gas escapes beneath the ice, lifting dust from the ground. It's a fascinating phenomenon, ice transforming directly into gas, reshaping terrain, and subtly stirring the planet's atmosphere. Spring on Mars is like a quiet awakening, with the poles releasing their frozen breath and the planet adjusting to a warmer, more active season. The sublimation of CO2 is a reminder that even a thin, cold world can have dynamic, almost magical processes. Fact 78. Mars has frost-covered mornings in winter. In addition to polar ice, frost can form in lower latitudes during winter nights. The cold, thin air allows water vapour to condense on rocks and soil, creating delicate frost patterns. Imagine waking on a Martian morning to see rocks glistening faintly, dust and soil sprinkled with icy crystals that quickly evaporate as the sun rises. These frosts are subtle, fleeting, but they leave lasting impressions for scientists studying seasonal cycles and local climate. Frost formation shows that Mars has small-scale weather processes, even in a seemingly barren landscape, and demonstrates the delicate balance of temperature, humidity, and surface conditions on the red planet. It's a tiny but beautiful sign that Mars isn't lifeless. It's alive with subtle rhythms waiting for careful observers to notice. Fact 79. Wind-shaped sand dunes over time. Mars winds may be thin, but they are persistent. Over years, decades, and centuries, they shape sand dunes across the plains and valleys. Patterns of ripples, crescent-shaped dunes, and shifting ridges are all created by the constant movement of fine particles. Imagine walking across a vast dune field in your mind. Subtle mounds rising and falling, slopes shifting under invisible currents of air, dunes slowly migrating across plains. Even without rivers or vegetation, Mars's winds sculpt the landscape, leaving delicate traces of movement over time. These wind-shaped dunes provide clues to prevailing wind directions, seasonal variations, and even local weather patterns. They remind us that Mars is a dynamic world, constantly reshaped by invisible forces, and that even small changes accumulate into noticeable effects. Fact 80. Dust storms can affect solar-powered rovers. Dust storms aren't just dramatic, they have practical consequences for exploration. Fine dust lifted into the air can cover solar panels, reducing power for rovers like Spirit, Opportunity, and even modern missions. Some storms become planet-wide, darkening skies for weeks and forcing engineers to manage energy carefully. Imagine a rover sitting quietly while a swirling red haze engulfs its surroundings, sunlight dimmed and instruments working with limited power. These storms are reminders that Mars is not a passive world. It can challenge explorers in subtle and extreme ways. Dust storms also reveal the planet's climate in action. By observing storm patterns, scientists learn about wind behavior, atmospheric pressure changes, and seasonal cycles. The storms are both a danger and a window into Mars' active environment, highlighting the balance between exploration and the planet's natural forces. Fact 81. Mars once had conditions suitable for life. Mars wasn't always the cold, dry world we see today. Billions of years ago, it had liquid water, a thicker atmosphere, and milder temperatures, conditions that could have supported life. Imagine rivers flowing gently across plains, lakes filling basins, and small pools forming in craters. These ancient environments suggest that Mars could have been a habitable planet, at least for simple organisms. The landscape, with its layered sediments, minerals formed in water, and gentle slopes, paints a picture of a world capable of sustaining life in some form. Understanding this past habitability helps scientists frame their search for life today. Even though the planet is harsh now, it once offered the essential ingredients: water, energy, and chemistry. Mars's history shows that a world can change dramatically over time, evolving from potentially life-friendly to the barren planet we see today. Fact 82. Scientists look for microbial fossils. To explore Mars' potential for life, scientists focus on microbial fossils, tiny structures in rocks, chemical signatures, and patterns in sediments can reveal traces of ancient organisms. These aren't fossils like dinosaurs, They're microscopic, subtle hints of life that existed billions of years ago. Imagine peering through a microscope at a thin Martian rock sample, finding layered patterns or mineral deposits that suggest life once altered the environment. Every discovery is a piece of a puzzle, helping reconstruct the planet's biological past. The search for microbial fossils combines geology, chemistry, and biology. Each sample, each observation, brings us closer to understanding whether Mars ever hosted life, giving a glimpse into the mysteries of a distant world that may have been more alive than we imagined. Fact 83. Organic molecules were detected by Curiosity. Curiosity rover made a breakthrough by detecting organic molecules in Martian rocks. Organic molecules are the building blocks of life. Though they don't prove life existed, they indicate that the planet had the raw ingredients necessary for biology. Imagine Curiosity drilling into rock layers millions of years old, analysing samples and finding tiny chains of carbon-based molecules. These discoveries show that Mars had complex chemistry, capable of supporting life processes. Organic molecules tell a story of potential. They hint at past environments where chemistry could evolve toward biology, at lakes and rivers that preserved delicate compounds, and at a planet that once held far more promise than its dusty surface suggests today. Fact 84. Water presence is a key factor for life. Water is essential for life as we know it, and Mars's watery past is central to the search for organisms. Ancient rivers, lakes, and possible underground aquifers create environments where microbes could have thrived. Imagine standing at the edge of an ancient Martian lake bed, the soil still containing traces of water-altered minerals. Even though the water is gone now, it left chemical fingerprints, sulfates, clays, and hydrated minerals that guide scientists to the most promising sites for searching for life. Water is the thread connecting Mars' geology and biology. Wherever it existed in the past, it increased the chances that life could develop, leaving hints for us to uncover billions of years later. Fact 85. Ancient lakes may have hosted bacteria. Some regions on Mars contain evidence of ancient lakes, where standing water persisted for thousands of years. These lakes could have been ideal habitats for microbial life, providing stable conditions, nutrients, and chemical energy. Imagine tiny bacteria, or something similar, living in shallow, quiet pools, their existence altering the surrounding sediments and leaving subtle traces behind. Over millions of years, these signs could fossilize, creating chemical or structural markers for modern rovers to detect. Exploring these lake beds is like reading a diary from Mars' past. Each sediment layer, mineral deposit, and trace fossil tells the story of water, chemistry, and the tantalizing possibility that life once flourished, even if only on a microscopic scale. Fact 86. Subsurface ice might shelter microbes today. Even though Mars's surface is harsh, its subsurface could be more forgiving. Beneath layers of soil and rock lies ice, and in some areas this frozen water may create pockets where microbes could survive. Imagine tiny organisms tucked away in cold, protected spaces, shielded from radiation and extreme temperatures above. These hidden refuges could offer the conditions necessary for life to persist. Liquid water in briny form, nutrients from surrounding minerals, and stability over long periods. Scientists study ice-rich regions not just for the history of water, but for the tantalizing possibility that life might still exist in these subterranean environments. The subsurface ice reminds us that Mars isn't uniformly barren. Even in the harshest world, there may be tiny sanctuaries where life endures quietly, out of sight, waiting for discovery. Fact 87. Mars's soil has chemicals that preserve organics. Mars soil contains chemicals that can protect organic molecules from breaking down. Perchlorates, clays, and salts interact with minerals to stabilize carbon-based compounds over long periods. These preserved organics act like time capsules, holding clues to the planet's past chemistry and potential biology. Imagine a rover scooping soil and finding compounds that survived for billions of years, giving scientists the rare chance to analyze them remotely. These molecules are fingerprints of past environments, showing that even after Mars dried up and cooled, some chemical traces endured. By studying preserved organics, scientists hope to understand whether life could have formed, how it might have existed, and how long chemical evidence can last in such a harsh environment. Even dusty, frozen soil becomes a record of Martian history. Fact 88. Methane spikes hint at possible biological activity. Methane in Mars' atmosphere is a mystery. Occasionally orbiters and rovers detect spikes in methane levels. On Earth, methane is often produced by living organisms, but on Mars it could also come from chemical reactions in rocks. Imagine a rover measuring the air above a crater and detecting a sudden burst of methane, a tiny signal from the planet itself. Scientists debate its origin, knowing it might be geological, or it could hint at hidden microbial life interacting with subsurface materials. These methane spikes spark curiosity and caution. They're fleeting, unpredictable, and localized, but they suggest that Mars isn't chemically inert. Something is active beneath the surface, whether life or geology, and the planet still has secrets waiting to be uncovered. Fact 89. Mars analogues on Earth help study survival. To understand how life could survive on Mars, scientists study extreme environments on Earth called Mars analogues. Places like Antarctica, the Atacama Desert, and deep caves mimic the cold, dry, and radiation-exposed conditions of the Red Planet. Imagine researchers testing microbes in salty soils, frozen lakes, or high-altitude deserts, observing how organisms cope with limited water, intense UV light, and nutrient scarcity. These studies guide missions on Mars, helping predict where life might exist, how to detect it, and what tools to bring. Earth analogues are crucial. They bridge the gap between imagination and reality, showing that life can adapt to extremes and that Mars may hold similar refuges. They prepare us to recognize subtle signs that could otherwise go unnoticed. Fact 90. Future missions aim to return samples to Earth. The ultimate goal of many Mars missions is to bring samples back to Earth. Rovers like Perseverance are collecting rocks, soil, and core samples that could one day be returned for detailed laboratory analysis. Imagine scientists opening a vial of Martian soil in a lab on Earth, examining every particle with instruments far too large or delicate to send to Mars. These samples could reveal organics, mineral history, and perhaps even traces of past life in ways impossible to study remotely. Sample return missions represent the next leap in exploration, combining robotic endurance with human curiosity. They bring the Red Planet closer than ever, transforming it from a distant world into something tangible, analyzable, and profoundly real. Fact 91. Mars has sunsets that appear blue. Mars offers a surprising twist. While the planet is known for red skies during the day, sunsets can appear blue. This happens because fine dust particles scatter sunlight differently than on Earth. Imagine the sun sinking slowly over the horizon, the sky glowing with soft blue hues, contrasting the red Martian landscape. These blue sunsets are subtle but mesmerizing. They hint at the unique atmosphere of Mars, where thin air and dust interact to create colors unlike anything on our home planet. Standing there, in your imagination, you'd feel a quiet serenity, a reminder that even a barren world has moments of beauty. Mars's sunsets reveal the delicate dance between sunlight, dust, and air. They're fleeting, yet they give the red planet an emotional depth, proof that color, light, and atmosphere together tell a story of environment and time. Fact 92. Imagine walking across its dusty plains. Picture yourself stepping across a Martian plain, the ground soft with fine dust, the horizon dotted with craters and distant hills. Each footprint leaves a trace in a world untouched by humans, a personal mark on a vast alien landscape. The air is thin. Sunlight diffused through the reddish haze, and the silence is profound. Unlike Earth, there's no rustling of leaves or water flowing, just the whisper of wind moving tiny grains of dust across dunes. Walking here would be both humbling and exhilarating, connecting you directly to a planet billions of years old. These plains are where history is written in soil and stone. Every step is a journey through time, over basaltic lava flows, dust-covered sediments, and ancient riverbeds that hint at a wetter past. The experience is quiet but full of discovery, a slow dance with the red planet itself. Fact 93. You could lie beneath the stars with thin air above. At night, Mars' thin atmosphere reveals a star-studded sky unlike Earth's. Imagine lying on the surface, looking up at countless stars with no clouds to obscure your view. The Milky Way stretches across the horizon, sharper and clearer in the thin, cold air. The silence is profound. No sound carries, and the only movement is a distant dust swirl or one of the moons crossing the sky. Mars's night is a personal observatory, where the universe feels intimate, vast, and immediately present. The thin air means that light travels differently, giving a unique clarity to celestial objects. Mars isn't just red and dusty. It's also a place to witness the cosmos in a raw, unfiltered way, reminding us of our connection to the stars. Fact 94. A calm Martian dawn is quiet and pink. Martian mornings begin with a delicate pink glow, soft and subtle across plains and valleys. Imagine waking to a dawn that creeps slowly, dust particles catching the first sunlight and scattering it into warm pastel hues. The silence is profound, broken only by the imagined whisper of wind across dunes or the faint clatter of dust falling from rocks. Unlike Earth's mornings, there's no chirping of birds or rustling of leaves, just stillness and soft light bathing the landscape. A Martian dawn is a gentle introduction to the day, revealing terrain slowly and patiently. It reminds us that even a planet that seems harsh can hold quiet, serene moments, where light and dust combine to create fleeting beauty. Fact 5. The moons move slowly in the night sky. Mars' two small moons, Phobos and Deimos, drift across the night sky differently than our moon. Phobos moves fast, rising and setting twice in a Martian day, while Deimos drifts slowly, taking more than a full day to orbit the planet. Imagine watching them overhead, Phobos racing across the sky like a fleeting shadow, while Deimos lingers, almost suspended, giving a sense of motion and rhythm to the quiet Martian night. Their irregular shapes and cratered surfaces hint at their mysterious origins, possibly captured asteroids. These moons add character to Mars' nights. They are subtle reminders that this planet, while smaller and seemingly barren, has its own celestial companions, moving in ways that are both familiar and alien, weaving an understated dance above the dusty plains. Fact 96. Dust storms shift the landscape silently. Mars' dust storms are powerful yet quiet sculptors of the landscape. Unlike storms on Earth, they don't rumble with thunder or crash with rain. Instead, they sweep across plains and valleys, moving fine particles and reshaping dunes over time. Imagine a vast expanse of reddish sand slowly shifting under invisible currents, leaving behind subtle ripples and new formations. Dust settles over rocks and craters, covering the marks of previous storms and continuously refreshing the surface. These silent changes record the passage of time, showing that even on a seemingly still planet, movement is constant. Dust storms reveal Mars' dynamic personality. They remind us that change doesn't always announce itself with noise. Sometimes it happens softly, patiently and invisibly, transforming the planet in ways that take years to notice. Fact 97. Martian valleys echo with ancient history. Mars's valleys are more than cracks in the surface. They are storytellers. Winding channels carved by ancient water, lava, or tectonic forces reveal a planet that was once alive with energy. Imagine tracing a deep canyon with your eyes, noting layers of sediment and rock that formed billions of years ago. Each valley holds clues about floods, rivers, or lava flows that shaped the terrain. Some valleys are narrow and sinuous, while others stretch wide, hinting at massive forces that once carved them. Exploring these valleys, imagined or via rover, is like reading chapters from Mars' autobiography. They echo with ancient history, preserving moments from a time when the planet was far more active and possibly even habitable. Fact 98. Craters hold secrets of cosmic collisions. Craters cover Mars like scars from a violent past. Each crater tells a story of an asteroid or meteorite striking the surface, reshaping the landscape instantly. Some are tiny, barely noticeable, while others are vast, with raised rims and deep basins. Imagine peering into a crater. Layers of ejecta, fractured rock, and dust reveal the impact's force and age. These craters are time capsules, preserving the record of cosmic collisions that have battered Mars over billions of years. Studying craters helps scientists understand not only Mars' history, but also the broader story of our solar system, showing how planets endure impacts and continue to evolve over time. Fact 99. Life may have existed long ago. The search for life on Mars is one of humanity's most captivating quests. Billions of years ago, conditions may have been right for microbial life. Liquid water, stable environments, and chemical nutrients. Imagine tiny organisms thriving in ancient lakes or beneath protective layers of soil. While no direct evidence of life has been found yet, organic molecules, minerals formed in water, and sedimentary layers suggest the planet once had the ingredients necessary for biology. This possibility transforms Mars from a distant red dot into a planet with stories and mysteries. Life may have existed, leaving subtle signs for us to discover, whispering that the red planet was once more than barren rock. Fact 100. Mars remains a serene, distant world to dream about. Even after all we know, Mars retains its quiet, mysterious beauty. Its red plains, towering volcanoes, and deep valleys evoke wonder. Imagine lying beneath the pink dawn, watching blue sunsets, tiny moons drifting overhead, and dust swirling gently across dunes. Mars is a planet of extremes and subtleties, harsh yet serene. It inspires curiosity, imagination, and dreams. Whether exploring it through rovers, orbiters, or our imagination, it remains a distant world we can marvel at while falling asleep, letting its silent landscapes carry us into thought and wonder. Mars reminds us of the vastness of the universe, the passage of time, and the delicate beauty of exploration. It's a planet to observe, to imagine, and to dream about, a perfect companion for quiet reflection under the stars.